Picture this: you step outside one evening, expecting the familiar glow of the moon hanging in the sky, only to find darkness. Not a cloud in sight, no storm to blame. Just an empty void where Earth's closest companion should be. At first, it feels like a strange glitch, a trick of the eye, but as the hours pass, reality sinks in. The moon is gone, vanished without warning. Social media erupts with confusion, scientists scramble for answers, and a quiet dread spreads across the planet. Because this isn't just about losing a beautiful sight in the night sky. The moon's disappearance would unravel the very fabric of life as we know it. Think about the tides first, those rhythmic pulses of the ocean that shape coastlines, guide marine life, and even influence our weather. Without the moon's gravity tugging at the Earth, the seas would turn sluggish, their waves weakening into mere ripples. Beaches we've known for centuries would vanish under stagnant water or retreat into barren stretches of sand. But the chaos wouldn't stop there. The Earth itself would begin to wobble like a spinning top, losing its balance, tilting erratically over time. Seasons, once predictable, would swing between extreme scorching summers, endless winters throwing agriculture into turmoil and threatening food supplies worldwide. And that's just the beginning. This isn't science fiction. It's a chillingly real possibility if our moon were to suddenly disappear. Over the next few minutes, we'll explore how this silent partner in the sky holds the key to Earth's stability, from stabilizing our climate to guiding ancient navigators, even shaping the length of our days. The consequences would ripple through every aspect of life, from the deepest oceans to the highest reaches of our atmosphere. So let's dive into the science behind this cosmic disaster scenario and uncover just how much we owe to the pale, unassuming rock orbiting quietly above us. Because once you understand its role, you'll never look at the night sky the same way again. Right now, Earth is tilted at about 23.5 degrees, a slight lean that gives us our seasons. Summer blooms when your hemisphere tips toward the sun. Winter arrives as it tilts away, but this balance isn't automatic. It's the moon with its steady gravitational pull that acts like a cosmic anchor, keeping our planet's tilt from veering into chaos. Without it, Earth would wobble wildly over thousands of years, like a spinning top losing its grip. Scientists believe our axis could shift anywhere from 0 to 85 degrees without the moon's stabilizing hand. Imagine winters so brutal they freeze oceans solid, or summers so intense they scorch continents into deserts. These aren't just dramatic shifts, they're extinction-level events. The moon's gravity also acts as a brake on Earth's rotation. Every century, our days grow slightly longer as the moon's tug slows us down by about 1.7 milliseconds. That might not sound like much, but over billions of years, it shaped the rhythm of life itself. Early Earth spun so fast that days lasted just 6 hours, a dizzying pace that would have made complex life nearly impossible. The moon's gentle resistance gave us the 24-hour day, a stable cycle that allowed plants, animals, and eventually humans to thrive. Without it, Earth might still be whirling like a frenetic top, with hurricanes raging non-stop and sunlight flashing by in brief, blinding bursts. Even the tides, often seen as the moon's most obvious effect, play a hidden role in stabilizing our climate. Ocean currents, driven by tidal forces, act like a planetary thermostat, distributing heat from the equator to the poles. Without the moon's pull, these currents would weaken, trapping heat in the tropics and plunging temperate zones into deeper cold. The result, a world of extremes where fertile land turns to tundra or wasteland within generations. Civilizations built over millennia could collapse as growing seasons vanish or crops bake under unrelenting sun. And here's the unsettling truth: we're already seeing glimpses of this instability. Mars, a planet without a substantial moon, wobbles wildly on its axis, its tilt shifting by 60 degrees over millions of years. The result, a fractured landscape of abandoned river valleys and frozen deserts, a warning of what Earth could become. The moon isn't just a pretty light in the sky, it's the silent guardian of everything we take for granted, from predictable weather to the very length of our days. Lose it, and we lose the delicate balance that makes our world livable. The ocean would become unrecognizable within hours of the moon vanishing, those powerful tides that rhythmically rise and fall. They'd flatline, reduced to mere shadows of their former selves, governed only by the much weaker gravitational pull of the distant sun. Coastal ecosystems that depend on the daily ebb and flow would face instant catastrophe. Imagine vast tidal zones, usually teeming with life, suddenly left high and dry as the water retreats permanently. Millions of crabs, mussels, and other creatures that evolved to survive brief exposures at low tide would be stranded, baking in the sun with no returning waves to rescue them. But the real horror might come from what happens beneath the surface. Without tidal currents to circulate nutrients, entire marine food chains would collapse. Plankton, the foundation of ocean life, thrives where moon-driven tides mix warm surface waters with colder, nutrient-rich depths. In this new stagnant sea, dead zones would spread like ink blots across the globe, suffocating fish populations that coastal communities rely on for survival. The sudden stop of tidal friction could even unleash geological nightmares. All that pent-up energy from Earth's rotation, no longer being gradually released by the moon's pull, might trigger monstrous undersea earthquakes. The result: tsunamis taller than skyscrapers racing toward shores that no longer have protective barriers of coral reefs already dying from the lack of tidal oxygen. And here's the cruel twist: even as some shores dry up, others would drown. The moon doesn't just create tides, it holds them in predictable patterns. Without its steadying influence, massive sloshes of water now restrained by ocean basins could go rogue. Picture the Mediterranean suddenly draining through the Strait of Gibraltar like a bathtub with the plug pulled, while the Caribbean swells into a monstrous inland sea, flooding Miami and Havana under meters of salt water. Shipping lanes would become impassable as harbors silt up or vanish entirely, stranding billions in stranded cargo and cutting off vital supply chains. This isn't just about losing pretty waves. The moon's gravity acts as Earth's metronome, keeping the ocean's heartbeat steady. Remove that rhythm, and within weeks, every coastal city would face impossible choices: abandon their waterfronts or spend trillions building Dutch-style dike systems. Fisheries that fed nations for centuries would become graveyards of rotting shellfish. The very chemistry of seawater would change as stagnant layers separate, with surface waters turning acidic from absorbed carbon dioxide, while deeper zones become toxic hydrogen sulfide baths. That iconic blue marble we see from space, it might soon be streaked with the ugly brown stains of dying seas, the first visible symptom of our planet's accelerating collapse without its celestial guardian. The intertidal zone, that narrow ribbon of shoreline where land meets sea, would become a wasteland almost overnight. These vibrant ecosystems, shaped over millennia by the moon's relentless tug, depend on the daily rhythm of submersion and exposure. Creatures like barnacles, sea stars, and anemones cling to rocks in precise vertical bands, each species adapted to survive exact durations of air and water. Without tides, the entire system collapses. The upper zones would dry out permanently, their inhabitants reduced to brittle shells under the unrelenting sun, while lower regions drown in stagnant water devoid of oxygen. The loss would ripple up the food chain. Shorebirds that rely on tide-exposed meals would starve, their migrations thrown into chaos as ancestral feeding grounds vanish. Coral reefs, already struggling under warming oceans, would face a new existential threat. Tidal currents flush reefs with nutrient-rich water and flush away harmful waste. In their absence, toxins would accumulate, choking the delicate polyps that build these underwater cities. the Great Barrier Reef, already bleached and battered, could turn into a lifeless skeleton within years. Fish that depend on reefs for shelter would scatter into open ocean, easy prey for predators, or worse, drift into dead zones where oxygen-starved waters suffocate them. The domino effect would be catastrophic. Nearly 1 billion people rely on reef fisheries as their primary protein source. Coastal communities from Indonesia to the Caribbean would watch their livelihoods and dinner plates empty in real time. Then there's the silent highway of the deep, the migratory routes shaped by tides. Salmon, sea turtles, and even tiny plankton ride tidal currents like conveyor belts to spawning grounds or feeding areas. Remove that lunar-powered transportation system, and entire generations get lost at sea. Humpback whales might miss their Antarctic feeding windows, their calves starving before reaching nutrient-rich waters. For species like the horseshoe crab, whose mass egg-laying synchronizes with high tides, extinction would be inevitable. These ancient rhythms aren't just biological quirks, they're the clockwork of ocean life. And humanity wouldn't escape unscathed. Global fisheries, worth over $160 billion annually, would implode as catch volumes plummet. Imagine supermarket seafood aisles stripped of shrimp, tuna, and cod, replaced by skyrocketing prices or empty freezers. The collapse would hit hardest in places like Peru, where anchovy fisheries feed both people and livestock, or Japan, where tidal flats nurture the shellfish underpinning its cuisine. But the crisis wouldn't stop at the water's edge. Seabird populations, critical for fertilizing coastal forests with nutrient-rich guano, would crash, triggering soil degradation that cripples terrestrial agriculture too. The cruel irony: we're already seeing a preview. During neap tides, when the moon and sun's gravitational pulls partially cancel each other, scientists observe temporary dips in marine productivity. But a moonless world would be neap tide forever, with none of the restorative spring tides to reset the balance. The ocean's heartbeat, steady for 4 billion years, would flatline, and with it, the intricate web of life that depends on its pulse. What we're really losing isn't just the moon's glow, but the invisible hand that shaped our planet into a cradle of biodiversity. The Earth would start spinning out of control, literally. Without the moon's gravitational drag acting as a cosmic brake, our planet's rotation would accelerate dramatically. Days that currently last 24 hours could shrink to a dizzying 6 or 8 hours. The change wouldn't happen overnight, but over centuries, the effects would transform everything from weather patterns to the basic rhythms of life. Think about the sheer force of that unchecked momentum. Hurricanes would intensify into perpetual superstorms, their winds fueled by a faster spinning planet. Deserts would expand as evaporation rates skyrocket under shortened daylight cycles, while polar regions might flash freeze during abruptly long nights. But the real danger lies beneath our feet. Earth's crust, suddenly freed from the moon's steadying influence, would begin shifting violently. The same tidal forces that once gently flexed our oceans also subtly stretched and compressed the solid ground. Remove that constant pressure, and the planet's tectonic plates, already grinding against each other, would unleash pent-up energy in catastrophic ways. Megaquakes, far stronger than any in recorded history, would ripple across fault lines as the crust adjusts to its new unbalanced state. Volcanic activity would surge, with magma chambers destabilized by the sudden change in gravitational stress. Regions like the Pacific Ring of Fire could erupt in near-constant fury, spewing enough ash to blot out the sun for years. Even more unsettling, the Earth's core might rebel. Our planet's molten outer core generates the magnetic field that shields us from deadly solar radiation. Some scientists theorize that the moon's gravity helps stabilize this churning metallic ocean. Without it, the core's dynamics could become erratic, weakening or even temporarily collapsing our magnetic shield. The result: cosmic radiation would bombard the surface, increasing cancer rates and frying delicate electronics. Satellites would fail, power grids would collapse, and communication networks worldwide would go dark. We're talking about a planet transformed into something almost alien, days flashing by in a blur, earthquakes rewriting coastlines, volcanoes darkening the sky, all while a weakening magnetic field leaves life exposed to the ravages of space. The moon doesn't just light our nights, it's the silent engineer maintaining Earth's delicate equilibrium. Lose it, and we don't just lose a celestial neighbor. We lose the stability that makes our world survivable. The axis of Earth would begin its terrifying dance within centuries of the moon's disappearance. That familiar 23.5-degree tilt, the reason we enjoy predictable seasons, would start oscillating wildly, swinging anywhere from 0 to 85 degrees like a pendulum without a counterweight. The consequences would make our current climate crises seem trivial. Picture this: one era, the poles could tilt directly toward the sun, baking Antarctica into a tropical swamp while the Arctic melts into a lifeless sea. Then, a few thousand years later, the entire planet might freeze over as both hemispheres lean away from solar warmth, triggering a new snowball Earth scenario. We've actually seen this horror show before. Around 700 million years ago, Earth experienced runaway glaciation that encased nearly the entire planet in ice, a phenomenon scientists suspect was caused by wild orbital fluctuations. But back then, life was mostly single-celled organisms huddled around hydrothermal vents. Today, our sprawling cities, industrial agriculture, and fragile ecosystems would face annihilation. The Sahara could shift to Europe while the Amazon transforms into a windswept tundra. Grain belts in the American Midwest and Ukrainian steppes would wither under extreme temperature swings, triggering global famines as food production collapses. Ice caps wouldn't just melt, they'd migrate. Current models suggest that without the moon's stabilizing pull, Earth's wobble could relocate the poles by thousands of kilometers. Imagine a world where Canada becomes the new equatorial rainforest while the equator itself freezes solid. Coastal megacities like New York and Shanghai, already struggling with rising seas, would face a worse fate: complete abandonment as climate zones shift faster than infrastructure can adapt. The very concept of spring planting or winter harvest would become obsolete as growing seasons vanish into erratic bursts of productivity followed by decades of barren soil. Historical precedents offer chilling glimpses. The Younger Dryas period 12,000 years ago saw temperatures in Greenland spike by 15 degrees Celsius in just a decade, a blink in geological time. But that event was caused by freshwater disrupting ocean currents. A destabilized axial tilt would unleash changes orders of magnitude worse, with temperature swings so abrupt they'd rewrite biomass within human lifetimes. Forests could die off before saplings mature, while animals migrating along ancient routes would find themselves trapped in alien climates, the most terrifying part. Unlike past extinctions, there'd be no refuge. During Snowball Earth, life survived in isolated pockets of liquid water. But modern civilization depends on global stability, shipping lanes, electrical grids, and supply chains all calibrated to our current climate. A world where deserts swallow fertile land overnight and ice sheets advance like bulldozers isn't just uninhabitable for polar bears or coral reefs. It's game over for industrialized humanity. The moon's gravity isn't just a celestial quirk, it's the regulator keeping Earth's climate from becoming a death trap. The night sky would become an alien canvas overnight, brighter yet emptier, its familiar rhythms erased. Without the moon's reflected glow to drown out fainter stars, constellations invisible for centuries would blaze into view. The Milky Way might shine with such intensity it casts shadows on the ground, a spectacle modern urbanites have never witnessed. But this cosmic light show comes at a devastating cost. Lunar eclipses, those breathtaking moments when Earth's shadow paints the moon copper red, would vanish from human experience forever. Future generations would read about them like ancient myths, never knowing the awe of watching our planet's silhouette glide across another world. For astronomers, both amateur and professional, the loss would be catastrophic. The Moon isn't just a pretty backdrop, it's a vital calibration tool. Telescopes use lunar craters to focus their lenses, while satellites rely on its reflective surface to bounce signals. Even space agencies depend on the Moon's gravity as a slingshot to propel probes deeper into the solar system. Without it, missions to Mars or beyond would require exponentially more fuel, potentially ending humanity's interplanetary ambitions before they truly begin. The cultural void might cut even deeper. For thousands of years, the Moon has been humanity's first calendar, its phases marking time for farmers, festivals, and faiths. Entire religions were built around lunar cycles: Islam's Ramadan, Judaism's Passover, even the dates of Easter. Indigenous cultures from the Inuit to the Maori structured their oral histories around the Moon's journey. Poets from Libai to Shakespeare wove its imagery into our collective imagination, while artists like Van Gogh captured its hypnotic glow. These connections would snap like severed threads in a moonless world. Perhaps most haunting of all, the Apollo landing sites, those fragile footprints and flags on the Sea of Tranquility, would become invisible relics. No longer could we point a telescope at the lunar surface and see where Armstrong took his giant leap. The very proof of humanity's greatest technological achievement would fade into cosmic darkness, leaving future skeptics to wonder if we ever left Earth at all. Ironically, the stars might finally get their due. Light pollution from cities already obscures 90% of the visible universe, but without moonlight washing out the heavens, even urban dwellers could glimpse thousands of stars. Ancient navigators who once used the Moon to traverse oceans might rediscover forgotten celestial techniques, steering by the North Star or Orion's belt instead. But this silver lining pales against what we'd lose: not just a celestial body, but the mirror that's reflected human dreams across the millennia. The night would gain stars, but our world would lose its soul. Humanity's dreams of becoming an interplanetary species would suffer a crushing blow without the Moon's presence. That pale disk in our sky isn't just a celestial neighbor, it's the ultimate stepping stone for deep space exploration. NASA Artemis program and international plans for lunar bases aren't just about revisiting old territory. These outposts were meant to be proving grounds where we could test life support systems, practice extracting water ice for fuel, and learn to survive in partial gravity before attempting the far more dangerous journey to Mars. Without this cosmic training ground, astronauts would be forced to make their first interplanetary attempts with untested technology, dramatically increasing the risk of catastrophic failure. The loss would extend far beyond cancelled moonwalks. The Moon's gravity well acts as nature's perfect launch pad, its low gravity requiring less fuel to escape than Earth's, while still providing enough pull to slingshot spacecraft toward distant targets. Every mission beyond Earth's orbit for the past 50 years has used this principle. From Voyager's grand tour to New Horizons' Pluto flyby, remove the Moon, and probes would burn through their entire fuel supply, just escaping Earth's grasp, leaving nothing for course corrections or scientific maneuvers. The Parker Solar Probe's record-breaking speeds, impossible without lunar gravity assists, those stunning images from the James Webb Space Telescope. Its delicate orbital dance at Lagrange Point 2 relies on precise balancing between Earth and Moon's gravitational forces. Mars colonization plans would face especially brutal setbacks. Current mission architectures depend on harvesting lunar ice to manufacture rocket fuel in space, a process that would become astronomically expensive if we had to launch all propellant from Earth's deep gravity well. The Red Planet's launch windows, already limited to brief alignments every 26 months, would become even narrower without the Moon's gravitational kick to extend our reach. We might see the dream of Martian cities postponed by centuries, trapped by the tyranny of rocket equations that the Moon once helped us cheat. Even more devastating, The loss of our cosmic time capsule, the Moon's airless surface, preserves 4 billion years of solar system history in its craters and lava plains, a record we've barely begun to decipher. Future astrobiologists might never trace the asteroid impacts that brought water to Earth, or study primordial solar wind particles trapped in lunar regolith. The very story of how life began on our planet could remain forever locked in that vanished archive, leaving fundamental questions about our cosmic origins unanswered. Private space ventures would collapse under the weight of these new limitations. Companies banking on lunar tourism or helium-3 mining would vanish overnight. Elon Musk's Starship, designed with Mars in mind but dependent on orbital refueling concepts tested first on the Moon, might never achieve its interplanetary potential. The entire economics of spaceflight would reset to Apollo-era constraints, where every kilogram launched from Earth carries crippling costs. That vibrant future of bustling space stations, asteroid mines, and Martian colonies. It all hinged on using our Moon as the universe's best launch platform, a silent partner in humanity's expansion across the solar system. Without it, we're not just losing a world. We're surrendering the keys to the cosmos. The global economy would hemorrhage trillions within years of the Moon's disappearance, not just from Earth-side chaos, but from the evaporation of the next great frontier, space resources. Helium-3, that rare isotope buried in lunar soil, was supposed to be the holy grail of clean fusion energy. Just 25 tons could power the entire United States for a year without radioactive waste or carbon emissions. Nations and corporations have already staked claims on potential mining zones, investing billions in extraction technology. With the Moon gone, these ventures would vanish overnight, along with the dream of limitless energy that could have ended fossil fuel dependence. The economic shockwaves would dwarf the dot-com bust and housing crash combined, except this time there'd be no recovery in sight. But helium-3 is just the tip of the iceberg. The Moon's crust holds platinum group metals in concentrations 10 times richer than Earth's deposits, along with rare earth elements crucial for everything from smartphones to wind turbines. Current mining operations strip mine entire mountains for mere grams of these materials. Lunar mining promised to flood markets with affordable supply, potentially slashing the cost of green technology and electronics. Instead, we'd face perpetual shortages, sending prices spiraling as tech manufacturers scramble for dwindling terrestrial reserves. The smartphone in your pocket. Its successor might never exist without access to space mine materials. Satellite networks would descend into chaos without the Moon's steadying influence. Geostationary orbits, carefully calibrated to hover over fixed points on Earth, rely on the Moon's gravity to maintain stability. Communication satellites would drift unpredictably, causing dropped calls, frozen video streams, and financial trading systems glitching worldwide. GPS accuracy, currently precise to within centimeters, could degrade to kilometer-level errors, making ride-sharing apps useless and causing cargo ships to run aground. The International Space Station itself might require constant repositioning burns to avoid drifting into dangerous trajectories, draining precious fuel reserves years ahead of schedule. Space tourism startups promising lunar flybys would fold immediately, their deposits refunded in bankruptcy court. Billion-dollar asteroid mining ventures, depending on the Moon as a fuel depot, would collapse like dominoes. Even mundane industries would think of all the lunar-themed products, from watches to cosmetics, that suddenly become morbid relics of a vanished world. The economic aftershocks would ripple through pension funds invested in space stocks, university astrophysics departments facing collapsed enrollment, and entire tech hubs like Silicon Valley seeing venture capital flee to safer bets. The cruelest twist, this economic black hole would form just as Earth struggles to adapt to climate chaos and food shortages. The very resources that could have saved us, clean energy isotopes, space-manufactured solar panels, off-world agriculture experiments, disappear along with our celestial partner. Future historians might record this as the moment humanity's expansionist dreams shattered against the harsh reality of a solitary planet. Without the moon's resources to fuel our ascent, we're left staring at the stars from an economic prison of our own making, one whose bars we didn't even realize existed until they slammed shut. Fields that once reliably fed nations would become battlegrounds of unpredictability. Without the moon's stabilizing influence on Earth's tilt, growing seasons would swing between extremes, some years bringing relentless frosts in June, others scorching droughts in April. Wheat, corn, and rice, crops finely tuned to predictable seasonal cycles, would struggle to complete their life cycles before being wiped out by abrupt climate shifts. Imagine Iowa's amber waves of grain frozen solid during an unseasonable blizzard, or California's Central Valley orchards blooming too early only to have their flowers blasted by a late heatwave. The delicate synchronization between pollination, rainfall, and harvest perfected over centuries of agricultural science would unravel in a matter of growing seasons. Soil health would collapse under these erratic conditions. Normally, winter freezes help break down organic matter while summer heat promotes microbial activity, a balanced cycle that maintains fertile ground. But with temperatures seesawing wildly, topsoil could either bake into lifeless dust or remain waterlogged for years, starving plant roots of oxygen. The Midwest's famed breadbasket might transform into something resembling the Dust Bowl era, but with one critical difference: there'd be no return to normalcy. Compounding the crisis, invasive pests normally kept in check by winter die-offs would thrive in the unstable climate. Locust swarms, emboldened by warmer average temperatures, could strip entire regions bare overnight, while fungal blights spread rapidly through crops stressed by irregular watering. Food security would shatter first in vulnerable regions. Countries like Bangladesh, where rice provides 60% of daily calories, might face complete crop failures multiple years in a row. The resulting famines would dwarf historic disasters like the Irish potato famine, which killed 1 million people. Now multiply that across dozens of nations simultaneously. Global grain reserves, typically holding just a few months' supply, would empty within weeks as panic buying overwhelms distribution networks. Supermarket shelves in wealthy nations would go from fully stocked to barren in days, with rationing systems collapsing under the strain. Modern farming's reliance on precision agriculture would backfire spectacularly. GPS-guided harvesters, programmed with decades of stable seasonal data, would find their algorithms useless when spring arrives 6 weeks early one year and 3 months late the next. Irrigation systems designed for predictable evaporation rates would either drown fields or leave them parched. Even genetically modified crops, engineered for specific climate ranges, couldn't adapt quickly enough to the roller coaster of temperature swings. The very technology that helped feed 8 billion people would become obsolete almost overnight. Perhaps the cruelest irony lies in carbon sequestration efforts. Projects like regenerative agriculture and cover cropping, meant to combat climate change by storing carbon in healthy soils, would become impossible to maintain. The same erratic weather-destroying crops would also disrupt these delicate soil-building practices, potentially releasing billions of tons of trapped carbon back into the atmosphere, accelerating the very crisis they were meant to mitigate. We're not just talking about higher grocery bills or the end of avocado toast. This is the collapse of civilization's most fundamental system, the chain linking sunlight, soil, and seeds that sustained humanity since the dawn of agriculture. Without the moon's steadying hand, we wouldn't just lose the beauty of moonlit nights. We'd lose the predictable rhythms that allowed farming to exist in the first place, condemning future generations to a precarious existence where every meal becomes a roll of the climatic dice. Our nights would grow darker, but the true blackness would seep into our minds. For millennia, the moon's gentle glow has acted as nature's nightlight, subtly syncing human biology to its cycles. Studies show that even when we don't directly see it, The moon's gravitational pull influences our sleep patterns. Deep REM sleep decreases by 30% during a new moon, while full moons correlate with 20 minutes less sleep on average. Without this celestial metronome, our circadian rhythms would spiral into chaos. Imagine nights where your brain can't decide whether to wind down or stay alert, where insomnia becomes the norm rather than the exception. The consequences would ripple far beyond tired mornings. Chronic sleep deprivation is linked to depression, weakened immunity, and even Alzheimer's disease. We might face a global mental health crisis unfolding in the shadows of a moonless sky. The artistic soul of humanity would hemorrhage inspiration. From Shakespeare's moonlight sonatas to Van Gogh's swirling starry nights, the moon has been muse to countless masterpieces. Modern filmmakers would lose their most dramatic backdrop. No more lunar eclipses heightening horror scenes. No more romantic moonlit walks in rom-coms. The very language of love would shrink. How many love songs reference the moon compared to the sun? Future generations might puzzle over ancient phrases like moonstruck or lunatic, words born from the once unshakable belief that lunar phases influenced human behavior. Even our concept of time would fracture. Before clocks, cultures from the Babylonians to the Mayans structured months around lunar cycles. Without that silver sickle marking the passage of weeks, would we feel time slipping through our fingers faster? Indigenous wisdom would face extinction. The Tlingit people of Alaska timed their salmon harvests by the moon's phases, while Polynesian navigators crossed thousands of ocean miles using lunar reflections on waves. These intricate knowledge systems, refined over centuries, would become obsolete overnight. Modern science isn't immune either. Lunar seismology helped us understand Earth's core, while studies of moonquakes revealed secrets about planetary formation. The blank space where the moon once hung would haunt astronomers like a missing puzzle piece in our cosmic origin story. Yet the most profound loss might be existential. That glowing orb taught humanity its first lesson in perspective, that we're part of something vast. When Apollo astronauts photographed Earth rising over the lunar horizon, it sparked the environmental movement by showing our planet as fragile and alone. Without the moon's silent companionship, would we feel adrift in the cosmos? The night sky wouldn't just lose a light, it would lose the mirror that showed us our place in the universe. Cultures that worshipped lunar deities might mourn not just a vanished god, but the death of wonder itself. Future children pointing at stars would never know the simple magic of tracing the man in the moon, an imaginary friend erased from the sky and the human psyche forever. Wolves would howl into a void that no longer answers. These apex predators, finely tuned over millennia to lunar cycles, rely on moonlight to coordinate hunts across vast territories. Under bright full moons, their pack communications carry farther, allowing strategic takedowns of large prey like elk or bison. Without that celestial spotlight, their success rates could plummet by half, triggering ecosystem chaos. Overgrown herds would strip vegetation bare, while starving wolf packs turned to livestock, igniting conflicts with ranchers that could push the species toward extinction. The haunting chorus of howls that has symbolized wilderness for centuries might fade into silence, leaving forests eerily quiet. Meanwhile, on tropical beaches, a tragic scene would unfold each night. Sea turtles, whose hatchlings have followed the moon's reflection to the ocean for 60 million years, would scramble blindly inland instead. Generations of instinct would become lethal misinformation as the brightest horizon glow shifts from moonlit waves to artificial city lights. Millions of tiny turtles would exhaust themselves crawling toward highways or predators, their yolk sacs depleting before reaching water. Conservationists estimate 70% of already endangered leatherback nests could fail within 5 years, a death sentence for species that take decades to mature. Coral reefs deprived of turtle grazers that control sponge growth would suffocate under unchecked competitors. The insect world would implode under similar confusion. Lunar moths, named for their moon-like eye spots, navigate by lunar polarization patterns invisible to humans. Their mating dances, synchronized to specific moon phases, would desynchronize, leaving swarms of males circling aimlessly while females die unmated. The ripple effects would starve bats and songbirds that rely on moth populations for summer feeding frenzies. Even humble zooplankton, which perform the planet's largest daily migration by rising to moonlit surface waters, would linger too deep for fish larvae to feed. Marine food webs could collapse from the bottom up like a house of cards. Migration patterns hardwired into countless species would disintegrate. Arctic terns, making their 25,000-mile annual journey, use the moon as a compass during overcast nights. With no lunar guide, these champion travelers might veer hopelessly off course, their epic voyages ending in exhaustion over featureless oceans. Monarch butterflies could lose their backup navigation system for cloudy days, dooming entire generations during critical northward expansions. The great wildebeest crossings of the Serengeti, already threatened by drought, would become chaotic stampedes as herds lose their ability to time river crossings with optimal lunar illumination. Perhaps most unsettling would be the explosion of urban-adapted predators. Rats and raccoons, less dependent on natural light cycles, would thrive as owls and foxes struggle. Cities already battling rodent infestations might see populations triple without lunar hunting predators keeping them in check. Disease risks from ticks and mosquitoes could skyrocket as traditional population controls falter. The delicate balance between predator and prey, refined over eons of moonlit nights, would tip violently toward species that thrive in humanity's shadow. We're not just losing celestial beauty, we're erasing the silent conductor of Earth's grand ecological orchestra. Every howl, flutter, and ripple in the night exists within a web of connections tuned to that distant glow. Break that rhythm, and the music of life itself falls into dissonance. The survivors wouldn't be the strongest or smartest, but those who adapt fastest to a world without its ancient guiding light, a world fundamentally rewired by absence. The ocean's hidden circulatory system would begin failing within weeks of the moon's disappearance. That steady pulse of tides doesn't just move water along coastlines, it drives the planet-wide network of currents that act as Earth's climate regulator. Without lunar gravity churning the seas, the great oceanic conveyor belt starts slowing like a failing heart. Warm surface waters that normally flow poleward from the tropics would stagnate, while frigid deep currents carrying oxygen and nutrients gradually grind to a halt. The first victims would be phytoplankton blooms, those microscopic forests that produce half the world's oxygen. Cut off from nutrient-rich upwellings, these green engines of the marine food web would wither, leaving dead zones larger than continents in their wake. Take the Gulf Stream as a horrifying case study. This mighty current, responsible for Europe's temperate climate, derives part of its power from tidal energy mixing waters along its path. With the moon gone, models suggest it could weaken by 30% within decades. The consequences read like a disaster novel, London facing winters colder than Moscow, while the Carolinas bake under tropical heat waves as stalled waters accumulate solar heat. Norwegian fjords might ice over year-round, disrupting global shipping lanes, while Caribbean coral reefs boil in bathwater-warm seas deprived of cooling currents. The real nightmare unfolds in the deep ocean, that frigid, oxygen-rich water currently sinking near Greenland. It's the engine driving the entire global circulation system. But without tides helping mix surface and deep waters, this critical sinking process slows dramatically. The result, a stratified ocean where surface layers become warm and stagnant while depths turn into toxic graveyards. We're already seeing previews in places like the Baltic Sea, where weak tides and limited circulation create some of Earth's largest dead zones. Now imagine that scenario going global, entire ocean basins where nothing survives except sulfur-breathing bacteria. Fisheries would collapse in cascading waves of extinction. Species like Atlantic cod that rely on tidal-driven currents to concentrate their prey would starve first. Then come the mass die-offs of filter feeders like oysters and mussels, their gills clogged by algal blooms flourishing in stagnant waters. Even apex predators wouldn't escape. Great white sharks tracking weakened currents might strand themselves on unfamiliar coasts, while tuna migrations veer wildly off course into oxygen-poor traps. The ocean's rhythmic heartbeat, steady for eons, would flatline into erratic spasms. Climate patterns would go haywire as the ocean's thermal regulation fails. Normally, currents distribute equatorial heat toward the poles with remarkable efficiency. But in this new stagnant sea, that heat builds catastrophically in the tropics while polar regions plunge into deeper cold. Hurricane formation zones could shift unpredictably, sending monster storms barreling into unprepared coastlines. Monsoon rains that feed billions might fail entirely as the temperature gradients that drive them dissipate. Even El Niño events, already disruptive, could become permanent fixtures, locking the Pacific into endless drought flood cycles. Marine scientists compare the ocean's circulation to a giant flywheel. Once set in motion, it resists change through sheer momentum. But remove the moon's constant nudging, and that flywheel gradually loses spin. What took nature 4 billion years to perfect could unravel within human lifetimes, leaving behind a broken climate system and a suffocating sea. The tides we watch with such casual admiration aren't just pretty waves, they're the steady hands turning Earth's greatest climate control knob. Lose them, and we don't just lose the moon's glow. We lose the dynamic balance that keeps our planet alive. The winds would howl with unprecedented fury as Earth's accelerated rotation rewrote the rules of atmospheric physics. Normally, our planet's 24-hour spin creates predictable wind patterns, trade winds flowing westward near the equator, jet streams snaking across latitudes, all governed by the Coriolis effect. But speed up that rotation, and these systems morph into chaos. Picture hurricanes spinning with such intensity their eyes stretch hundreds of miles wide, fed by winds exceeding 300 miles per hour. These wouldn't just be storms, they'd become self-sustaining atmospheric beasts, lingering for months as they devour warm ocean waters like immortal vampires. Coastal cities might face perpetual evacuation cycles, their skyscrapers reduced to skeletal frames by relentless wind abrasion. The jet streams, those high-altitude rivers of air that steer weather systems, would unravel into tangled knots. Current models suggest a faster spinning Earth could split the polar jet into multiple competing currents, creating bizarre weather whiplash. One week, Texas freezes under Arctic air pulled unusually far south. The next, Alaska bakes under tropical humidity. Rainfall patterns would become wildly erratic, with some regions drowning under years of non-stop deluges, while others transform into drought-stricken wastelands overnight. Agricultural zones carefully mapped over centuries would become meaningless as climate belts shift faster than crops can adapt. But the true atmospheric nightmare might come from above. Earth's magnetosphere, that invisible force field deflecting deadly solar radiation, relies on our molten outer core's constant churning. The moon's gravity helps stir this metallic ocean through tidal heating, like a spoon swirling in a pot. Remove that stirring mechanism, and the core could gradually cool and solidify in patches. The result, holes in our planetary shield where cosmic rays pour through unimpeded. Satellite constellations would fry first, their delicate electronics overwhelmed by particle bombardments. Then surface radiation levels would climb, not enough to kill immediately, but sufficient to spike cancer rates and mutate ecosystems over decades. Airline passengers might start absorbing transatlantic radiation doses equivalent to chest X-rays, while high-altitude cities face increased UV exposure as the ozone layer degrades. We've actually seen this scenario play out on Mars. The red planet's lack of a substantial moon allowed its core to cool billions of years ago, shutting off its global magnetic field. The solar wind then stripped away most of its atmosphere, leaving the surface barren and irradiated. Earth wouldn't face such extreme consequences immediately. Our larger size buys us time, but the trajectory would be chillingly similar. Over millennia, we might watch our skies thin as solar particles blast away atmospheric gases molecule by molecule. The vibrant blue that nurtured life for eons could fade into a pale, anemic haze. Nighttime might reveal the most haunting change. Without a magnetic field to deflect them, charged particles from solar storms would slam directly into the upper atmosphere, painting the skies worldwide with auroras, not just near the poles but everywhere. At first, these shimmering curtains of light would dazzle observers, but their beauty would signal something ominous. Each colorful display represents our atmosphere being ionized, stripped apart by relentless cosmic forces. The same phenomenon that creates the northern lights also, over vast timescales, destroys planetary atmospheres. These atmospheric transformations wouldn't just alter our weather, they'd rewrite the very definition of habitable. The stable climate bands that allowed human civilization to flourish would become relics of a bygone era, replaced by a world where surviving the elements requires bunker-like infrastructure. Future generations might look back at our era of predictable seasons and calm skies with the same disbelief we reserve for tales of the Garden of Eden, a paradise lost not through human folly alone, but by the silent vanishing of a celestial anchor we never fully appreciated until it was gone. The very concept of time would unravel as Earth rotation accelerates days, shrinking from 24 hours to potentially just 6 or 8. Stock markets programmed for precise trading windows would glitch as algorithms struggle to recalibrate to rapidly shortening sessions. High-frequency trading systems that execute millions of transactions per second could collapse under the strain, triggering financial meltdowns as trades time-stamped in the old system clash with the new reality. International time zones, already a delicate patchwork, would fracture into chaos. Imagine Tokyo and New York trying to schedule a call when their noon shifts unpredictably each month. Diplomatic summits, global broadcasts, even airline schedules would descend into anarchy. Our digital infrastructure would face unprecedented stress. Every computer system built in the last 70 years assumes a 24-hour day. From the code behind your smartphone's alarm clock to the atomic clocks governing GPS satellites. Software patches might temporarily adjust, but hardware like older industrial machines or medical devices could fail catastrophically when their internal clocks spin out of control. Power grids synchronized to precise daily demand cycles would buckle under the strain, triggering rolling blackouts as operators scramble to match generation with wildly shifting human activity patterns. The internet itself, relying on time stamps for everything from banking transactions to video streaming, might slow to a crawl as servers overwhelmed trying to reconcile conflicting temporal data. Daily life would become a logistical nightmare. Commutes planned around rush hour would disintegrate as morning and evening compress into fleeting moments. School schedules, work shifts, even television programming, all built around reliable 24-hour blocks, would require constant revision. Farmers might find their livestock's breeding cycles disrupted, as animals relying on daylight cues grow confused by the sun racing across the sky 3 times faster. Sports leagues would face impossible choices: shorten games to fit the new reality, or risk matches stretching across multiple dawns and dusks. The most profound disruption might be biological. Humans evolved with circadian rhythms tuned to Earth's rotational speed. Our cells literally contain molecular clocks anticipating a 24-hour cycle. Studies show shift workers already suffer higher rates of cancer and heart disease when their rhythms break. Now imagine entire populations living with days shrinking by milliseconds each week, a creeping exhaustion no caffeine could fix. Sleep disorders would skyrocket as melatonin production struggles to adapt. while seasonal depression could become a year-round plague as daylight exposure fragments into erratic bursts. Religions would face existential challenges. Muslim prayer times tied to solar positions could require recalculations 5 times daily instead of once a year. Jewish Shabbat, beginning at sunset Friday, might last mere hours instead of 25. Even secular holidays would drift. Your birthday could migrate through seasons within a decade. Historians might one day divide time into before lunar loss and after lunar loss epochs, the ultimate testament to how deeply our vanished companion ordered human existence. This isn't just about resetting watches, it's about the collapse of civilization's fundamental metronome, the shared rhythm that synchronized everything from stock trades to school bells. Without the moon's gentle break on our planet's spin, we wouldn't just lose nights, we'd lose the very framework that made modern life possible. For countless cultures across millennia, the moon wasn't just a celestial object, it was a divine presence woven into the fabric of faith. The sudden disappearance of this sacred luminary would trigger spiritual earthquakes far beyond disrupted calendars. In Islam, where Ramadan's start and end hinge on the crescent moon's sighting, entire theological frameworks would fracture. Picture devout communities gazing skyward night after night, waiting for a sign that will never come. The Hadith's explicit lunar references, like the Prophet's description of Judgment Day when the moon is split, would take on eerie new meanings, leaving scholars scrambling to reinterpret scriptures suddenly divorced from physical reality. Mosques worldwide might face impossible choices: abandon moon-based rituals entirely or simulate phases through artificial lighting, reducing celestial worship to theater. Hinduism's connection runs even deeper. Chandra, the moon god, isn't just a timekeeper but a life-giver. His waxing and waning govern the growth of medicinal herbs in Ayurvedic tradition. The festival of Karva Chauth, where wives fast until moonrise for their husband's longevity, would lose its cosmic anchor. Without the moon's cooling rays to balance Surya, the sun god's heat, Vedic cosmology predicts a descent into unchecked fiery imbalance, a metaphor that may become terrifyingly literal as Earth's climate destabilizes. Similarly, Buddhism's Vesak festival, commemorating the Buddha's birth, enlightenment, and death under full moons, could dissolve into confusion, stripping the faith of its most visually potent spiritual symbol. Meanwhile, East Asia's Mid-Autumn Festival, a celebration of harvest and family unity for over 3,000 years, would become a gathering steeped in collective grief. The iconic mooncakes stamped with lunar motifs would taste like ashes in celebrants' mouths, their round shapes mocking the void above. In South Korea, where Chuseok rituals include offering rice to ancestors by moonlight, future generations might whisper apologies to spirits deprived of their celestial conduit. Indigenous traditions face even starker ruptures. The Lakota people's monthly moon-counting ceremonies, which mark communal renewal, would lose both calendar and sacrament simultaneously, a double amputation of cultural memory. Yet from this spiritual vacuum, new mythologies would inevitably emerge. Ancient societies created gods to explain eclipses and comets. Modern humanity would surely birth fresh cosmologies to make sense of the absence. Conspiracy cults might claim the moon was never real, just a holographic projection hiding some cosmic truth. Tech billionaires could be worshipped as new moon makers, their failed orbital mirrors becoming objects of twisted reverence. Artists might reimagine lunar deities as tragic figures, their ballads describing a goddess kidnapped by dark matter or a god who sacrificed himself to save Earth. Within decades, children's books could speak of the moon in the past tense alongside dinosaurs and dragons, transforming astronomical fact into legend. The most poignant transformations might occur in language itself. Words like lunatic from Luna, the Roman moon goddess, or the Japanese term tsuki ga kairi, literally, the moon is beautiful, a poetic confession of love, would become hollow metaphors, their origins fading like light from a dead star. Future poets attempting to capture romance or madness would need entirely new imagery, just as their ancestors once abandoned references to forgotten gods. This linguistic shift would mark the final phase of the moon's cultural death, when even the memory of its meaning dissolves into the same darkness that swallowed its physical form. What emerges from this crisis may not be entirely bleak. Just as the Apollo moon landings inspired global unity, the shared trauma of loss could spark unprecedented interfaith dialogue. Buddhist monks and Mayan calendar keepers comparing notes on celestial grief, imams and Wiccans creating hybrid rituals to fill the void. The universal experience of staring at an empty sky might forge new spiritual connections across traditional divides, but make no mistake, this would be evolution born of necessity, not inspiration. The cost of these new mythologies, the erasure of humanity's oldest cosmic companion, and with it the celestial mirror that shaped our souls for thousands of generations. Humanity wouldn't go down without a fight, and the first battleground would be the empty void where the moon once hung. Engineers have already sketched radical concepts to replicate our lost companion's functions, starting with tidal stabilization. Massive artificial gravity satellites anchored in Lagrange points could theoretically mimic the moon's gravitational pull. These megastructures, imagined Death Star-sized spheres of ultra-dense material, would orbit Earth precisely to tug oceans into rhythmic motion. The energy requirements alone stagger the mind. Each satellite might need the output of 1,000 nuclear reactors just to maintain position, but the real obstacle: scale. To truly replace the moon's tidal influence, we'd need hundreds of these behemoths, a construction project dwarfing every human engineering feat combined. The price tag could bankrupt nations, but the alternative, a stagnant, dying ocean, might leave no choice. For nighttime illumination, orbital mirrors offer a more elegant solution. Vast solar sails positioned in geostationary orbit could reflect sunlight to specific regions, simulating moonlight on demand. Japan's Shimizu Corporation once proposed a lunar ring of reflectors to brighten disaster zones. Scaling this up could patch the cultural wound of a moonless sky. Yet the unintended consequences could be dire. Artificial light pollution might disrupt ecosystems already reeling from the moon's disappearance. Nocturnal animals confused by constant full moon conditions could abandon essential behaviors, while astronomers would protest the loss of pristine dark skies. And then there's the geopolitical nightmare: who controls the dimmer switch? Countries might weaponize these mirrors, plunging rivals into perpetual darkness or scorching their crops with concentrated beams. The most audacious proposal involves hijacking an asteroid. NASA's DART mission proved we can alter celestial trajectories. Why not steer a near-Earth object into stable orbit as a makeshift moon? Ceres, the dwarf planet in our asteroid belt, has enough mass to influence tides if positioned correctly, but the risks are apocalyptic. A miscalculation could send it crashing into Earth, and even a successful capture would require centuries of precise orbital adjustments. Meanwhile, fringe groups might advocate for more extreme measures, pumping stratospheric aerosols to cool the planet, or building continent-sized underground farms to escape the climate chaos. Feasibility debates rage behind closed doors. Space agencies quietly run simulations showing that partial solutions, say a dozen small gravity satellites, might mitigate the worst tidal collapses, but only if deployed within decades. Private companies like SpaceX could repurpose starships as mirror deployers, but profit motives might prioritize lighting wealthy cities over saving collapsing fisheries. And all these fixes share a fatal flaw: they address symptoms, not the root cause. No human technology can fully restore the moon's 4 billion-year role as Earth's stabilizer. We'd be applying band-aids to a gaping cosmic wound, buying time at astronomical cost for civilizations that may never adapt. Perhaps the cruelest twist lies in the mirrors themselves. Future children gazing at their reflected glow would see not the comforting face of the man in the moon, but the cold sheen of human desperation, a reminder that some losses, no matter how fiercely we fight, can't be undone with engineering alone. The sudden disappearance of the moon wouldn't just destabilize Earth, it would force humanity to confront an uncomfortable truth. Our planet is no longer the safe harbor we imagined. With climate systems collapsing and axial wobbles threatening civilization's foundations, Mars transforms from a scientific curiosity into the only viable lifeboat within reach. This cosmic crisis could ironically become the catalyst that finally propels us to become a multi-planetary species. But there's a cruel twist: without the moon's training grounds, the challenges of Martian colonization multiply exponentially, turning an already Herculean task into something bordering on impossible. Consider the brutal math. Normally, Mars colonization plans rely on using the moon as a testing ground, a place to perfect closed ecosystems, radiation shielding, and low-gravity agriculture before attempting the far more dangerous journey to the red planet. The lunar surface offers a proving ground just 3 days from Earth, where failures can be quickly corrected and astronauts evacuated if necessary. Lose that stepping stone and we're forced to conduct all testing either on Earth, with its completely different gravity and conditions, or gamble with untried systems on Mars itself, where mistakes mean certain death. Every technology from water extraction to 3D printed habitats would need to work perfectly on the first attempt, with no intermediate failures allowed. The human cost becomes staggering when scaled to billions. Current Mars mission architectures assume small, highly trained crews making incremental progress over decades. But with Earth potentially becoming uninhabitable within centuries, we'd need to shift from sending hundreds to transporting millions, a logistical nightmare without orbital infrastructure. Rockets launching directly from Earth's deeper gravity well would require impossible amounts of fuel without lunar refueling stations. Even Elon Musk's most optimistic Starship projections, 1 million settlers by 2050, pale against the need to relocate significant portions of Earth's population before climate shifts render agriculture impossible. The selection process alone would spark global conflict. Who gets prioritized when escape seats number in the thousands but needy souls in the billions? Mars itself presents fresh horrors without lunar preparation. The planet's thin atmosphere and lack of magnetic field expose settlers to radiation levels 200 times higher than Earth's, a problem the moon could have helped solve by testing underground habitats and shielding technologies. Dust storms lasting months would cripple solar panels, forcing reliance on untested nuclear power. Most critically, Martian gravity, just 38% of Earth's, might prove insufficient to prevent the muscle atrophy and vision problems observed in microgravity, meaning colonists could arrive only to slowly degenerate into non-functional bodies. Without lunar studies to confirm whether 1/6 gravity provides adequate health benefits, we'd be gambling entire civilizations on an unknown variable. The psychological toll could be deadlier than any technical failure. Isolated crews on Mars would experience 20-minute communication delays with Earth, a manageable inconvenience for scientists but catastrophic for populations fleeing chaos. Imagine watching live feeds of your home continent descending into climate warfare while knowing help can't arrive for 2 years. Generations born on Mars might develop entirely new cultures oriented around survival rather than exploration, viewing Earth not as a cradle but as a failed experiment best forgotten. The very concept of humanity could split into divergent evolutionary paths within centuries, yet waiting isn't an option. Every year without the moon's stabilizing influence accelerates Earth's climatic disintegration, shrinking the window for orderly migration. The brutal irony: the technologies needed to escape mass spaceflight infrastructure, closed-loop life support, asteroid mining were all meant to be perfected on the moon first. Now we must invent them amidst the crisis they were supposed to prevent, like building lifeboats during the shipwreck. Perhaps this is the ultimate test of our species' ingenuity, to lose our celestial training wheels and still reach for the stars. But as we gaze at the empty space where the moon once hung, one haunting question remains. Are we clever enough to survive our own cleverness, or will we join the fossils of those species who put all their eggs in one planetary basket? The clock is ticking, and Mars won't wait. The solar system's delicate gravitational ballet would spiral into chaos without the moon's steadying presence. That familiar lump of rock orbiting Earth does more than light up our nights. It acts as a cosmic shield, its gravity deflecting countless asteroids away from collision courses with our planet. Remove that celestial bodyguard, and Earth suddenly becomes a sitting duck in an interstellar shooting gallery. Near-Earth objects that once sailed harmlessly past might veer dangerously close, drawn by our planet's unopposed gravitational pull. The math is terrifying. Some models suggest impact risks could triple within decades as destabilized orbits send space rocks tumbling inward like pins in a cosmic bowling alley. Consider the case of 3753 Cruthen, that bizarre quasi-moon sometimes called Earth's second moon. This 5-kilometer-wide asteroid dances in an intricate horseshoe orbit stabilized by complex interactions between Earth, the Moon, and the Sun. Take the Moon out of the equation, and Cruthen's path could destabilize, potentially transforming it from a harmless curiosity into a civilization-ending projectile. Similar fates might await hundreds of other near-Earth asteroids currently kept in check by the Moon's subtle gravitational nudges. Even the infamous Apophis, that stadium-sized rock once feared to hit Earth in 2029, might find its trajectory altered just enough to bring doomsday scenarios back into play. Venus offers a chilling preview of this unstable reality. While Earth enjoys a relatively stable axial tilt thanks to our moon, Venus wobbles wildly between 177 and 120 degrees over billions of years. Some astrophysicists attribute this erratic behavior to Venus lacking a substantial moon to stabilize its rotation. The consequences are apocalyptic surface temperatures hot enough to melt lead, crushing atmospheric pressures, and days that last longer than its years. Earth wouldn't face identical conditions without the moon, but Venus's chaotic existence serves as a stark warning. In the cosmic arena, stability is the exception, not the rule. The real danger lies in the cascading effects. A single major asteroid impact could trigger a chain reaction of disasters. Dust clouds blocking sunlight for years, global wildfires, acid rain poisoning the oceans. The dinosaurs faced one such catastrophe 66 million years ago when a 10-kilometer rock slammed into the Yucatan Peninsula. Today, with human civilization covering the planet and depending on fragile supply chains, even a much smaller impact could collapse modern society. Cities built near coastlines would face tsunamis hundreds of meters high, while agricultural heartlands could be rendered sterile by impact winters lasting decades. Ironically, the moon itself bears witness to this violent past. Its pockmarked surface tells the story of an early solar system far more dangerous than today's, a time when planetary orbits were still settling into their current arrangements. Those ancient craters represent impacts that might have struck Earth instead, were it not for the moon's gravitational influence. Remove our celestial guardian, and we might return to that primordial chaos with space rocks once again raining down in terrifying numbers. Future generations wouldn't just miss the moon's gentle glow, they'd long for its protective shadow, never realizing how much safety its silent presence provided until disaster came calling from the stars. What makes this threat particularly insidious is the delayed reaction. Unlike the immediate climate chaos or tidal collapse, the asteroid hazard would creep up over decades and centuries as orbits gradually destabilize. Early generations might breathe easy, seeing few impacts in their lifetimes, only for their descendants to inherit a solar system growing increasingly hostile with each passing year. By the time the danger became obvious, it might be too late to rebuild the celestial defenses we took for granted. The moon's absence wouldn't just leave a hole in our sky, it would open a cosmic doorway for destruction we're only beginning to understand. Clocks would become relics of a bygone era overnight as humanity scrambles to rebuild time itself around 6-hour days. The first casualty, the 9-to-5 workday, now absurdly impractical when days flash by in a quarter of their former length. Instead, societies might adopt rolling micro-shifts synchronized to the body's new reality. 90 minutes of activity followed by 30-minute rest periods, cycling continuously like train cars on a loop. Emergency rooms would staff 10 separate teams rotating through perpetual twilight, while schools fragment lessons into 15-minute bursts optimized for shortened attention spans in a world without circadian anchors. The tech overhaul would dwarf the Industrial Revolution. Smart cities would deploy adaptive lighting grids that simulate sunrise every 6 hours, tricking brains into accepting artificial days. Offices might install rapid reset circadian pods, think tanning beds crossed with sensory deprivation tanks, where workers plug in for 20-minute neural resets. Agriculture faces the biggest hurdles. Vertical farms running under pulsating LED sequences could replace traditional fields, with crops genetically modified to complete photosynthesis in half the time. The most radical solution, bioengineered algae that generate oxygen efficiently under near-constant darkness, potentially floating in massive oceanic pods to supplement failing terrestrial ecosystems. Cultural rituals would rewrite themselves around the tyranny of speed. Birthdays might celebrate every 100 days instead of years, turning 30 into the new 70. Sports leagues would compress games into frantic 40-minute sprints, while religions invent high-frequency holidays. Imagine Christmas morning, afternoon, and evening all in one solar rotation. Sleep science becomes the ultimate status symbol, with elite time architects crafting personalized polyphasic cycles for CEOs and politicians. The poor, they'll suffer under outdated 8-hour sleep expectations crammed into fractured time blocks, fueling a new epidemic of exhaustion-induced errors. Yet some communities might reject the frenzy altogether. Underground bunker cities could emerge where die-hard traditionalists enforce 24-hour cycles via artificial sun lamps, preserving biological rhythms at the cost of total disconnection from the surface world's chaotic tempo. Their children, born never knowing true daylight, might view Earth's accelerated spin as humanity's original sin, a cosmological fall from grace, the bitter irony. This desperate clinging to obsolete timekeeping could become the ultimate luxury, affordable only to those who controlled the last vestiges of stable technology before the great unraveling. The true test comes when we ask what time even means in this new reality. Ancient sundials measured the sun's journey, mechanical clocks mimicked celestial motions. But in a world spinning unmoored from cosmic rhythms, do minutes and hours retain meaning, or do we invent entirely new units, divorced from planetary rotation entirely? Perhaps we'll measure life in wakes instead of days, tracking consciousness cycles rather than sunrises. Our descendants might puzzle over why their ancestors obsessed with dividing time into 24 equal slices, just as we marvel at Babylon's base 60 system. One thing's certain, whoever masters the art of temporal redesign in this chaotic new era won't just control schedules, they'll redefine what it means to be human in a universe suddenly stripped of its most familiar rhythm. As Earth's axis wobbles toward chaos and solar farms falter under erratic daylight, humanity's energy infrastructure would face a reckoning. Geothermal emerges as the most reliable survivor in this unstable new world. Tapping into the planet's molten heart offers a tantalizing constant. Underground temperatures remain steady even as surface weather veers between ice ages and heat waves. Iceland's volcanic landscapes already prove the concept, with geothermal providing 90% of the country's heating and a quarter of its electricity. But scaling this globally means drilling deeper and hotter than ever before. Next-generation enhanced geothermal systems could fracture bedrock miles down, creating artificial reservoirs where none exist naturally. The catch: triggering seismic activity becomes inevitable. Cities built near fault lines might trade blackouts for the constant low rumble of induced earthquakes, a Faustian bargain for keeping lights on. Nuclear steps into the spotlight with renewed urgency. Small modular reactors designed for rapid deployment could replace dying grids with factory-produced units no larger than shipping containers. Imagine trucks delivering atomic power plants to disaster zones like bottled water after a hurricane. Thorium molten salt reactors, shelved during the Cold War in favor of uranium weapons programs, offer meltdown-proof designs that consume nuclear waste as fuel. Yet speed breeds risk. Accelerated construction schedules might compromise safety protocols, while scarce rare earth metals for reactor parts spark resource wars. The very technology meant to stabilize civilization could become its newest fault line if corners are cut in the race against time. The boldest solution hovers 22,000 miles overhead. Orbital solar farms, once the domain of sci-fi schematics, transform into existential necessities. These megastructures unfurl solar panels spanning square kilometers, beaming energy via microwaves to retina stations on Earth's surface. Japan's space agency already demonstrated the core technology, transmitting power wirelessly in 2025. Without moonlight illuminating nighttime solar panels, these orbital arrays could provide 24-hour baseload power, their geostationary orbits keeping them in perpetual sunlight. The economics shift from speculative to survivalist when traditional grids fail. Yet space-based power introduces cosmic-scale vulnerabilities. Solar storms could fry delicate orbital electronics, triggering cascading failures across continents. The microwave beams themselves might be hijacked as weapons, a single degree's miscalibration turning a power transmitter into a city-scorching death ray. And the launch logistics boggle the mind. Constructing just one solar satellite could require thousands of Starship launches, each carrying payloads through an increasingly debris-cluttered exosphere where the Moon's gravity once swept clean our orbital pathways. Hybrid systems may offer the wisest path forward. Deep geothermal anchors the grid with brute force reliability, nuclear handles peak demands, and orbital solar stitches together the gaps, each compensating for the other's weaknesses. The transition wouldn't be pretty. Picture drill rigs towering over suburban neighborhoods, nuclear convoys rumbling down interstate highways, and microwave receiver farms sprawling across deserts like alien crop circles. But in a world where the sun can't be trusted and the moon's gone dark, energy diversity becomes the ultimate insurance policy. The real innovation won't be any single technology. It's rebuilding civilization's foundation on the understanding that nothing, not even daylight, can be taken for granted anymore. Humanity's biology would rewrite itself under the unrelenting pressure of eternal night. Over generations, our irises might expand like those of deep-sea creatures, pupils dilating to capture every stray photon in the moonless dark. Evolutionary pressures could favor mutations like the tapetum lucidum, that reflective layer behind animal retinas causing eye shine, turning nocturnal workers into efficient predators of the shadows. Children born with these adaptations would navigate blackout cities effortlessly while their sun-dependent ancestors stumble, creating a genetic divide as stark as the split between early humans and Neanderthals. Sleep patterns would fracture into entirely new configurations. The classic 8-hour block, already a relatively modern invention, might shatter into polyphasic bursts, 20-minute power naps scattered across 6-hour days, or hibernation like torpor during extended axial tilt winters. Epigenetic changes could silence genes linked to traditional circadian rhythms, replacing them with flexible systems more akin to dolphins' unihemispheric sleep. Future office workers might dose themselves with synthetic melatonin cocktails, hacking their biology to match artificially lit work cycles, while underground, darkness cults deliberately breed for extreme wakefulness, valuing the ability to function on 90 minutes of sleep per rotation. The most radical transformations could emerge from deliberate bioengineering rather than natural selection. CRISPR-enhanced skin might incorporate bioluminescent bacteria like those found in flashlight fish, granting humans the ability to glow on demand for communication or navigation. Synthetic biology startups could offer gene therapies to implant opsins, light-sensitive proteins from jellyfish directly into retinal cells, enabling night vision so sharp it renders headlamps obsolete. Military units might pioneer these enhancements first, creating super soldiers who see in infrared while civilian populations lag behind, sparking a new kind of sensory class divide. Urban environments would accelerate these changes through brutal practicality. In megacities where electricity becomes unreliable, those with genetically brighter irises or faster dark adaptation would dominate nighttime economies, while daywalkers cling to obsolete solar schedules. Dating apps could filter matches by circadian genotype, ensuring couples share compatible sleep mutations. The very concept of beauty might shift, pale, light-reflective skin becoming coveted as a status symbol, while sun-tan complexions mark the biologically disadvantaged. Yet nature's solutions could outpace our ingenuity. Some human populations already carried genes for enhanced night vision, like the Sama-Bajo sea nomads whose spleens adapted for deep diving. Given enough generations, similar spontaneous mutations might arise globally, perhaps even reawakening ancestral traits from our pre-agricultural past when humans hunted at dusk and dawn. The irony is profound. Losing the moon could force us to reclaim biological gifts our civilization had rendered unnecessary, trading the comforts of artificial light for eyes that pierce darkness like our Paleolithic forebears. The ultimate adaptation may not be inventing new abilities, but remembering old ones buried deep in our DNA. Language itself would mutate to describe these new realities. Words like lunacy, or once tied to lunar cycles, might evolve to mean day blindness, while moonlit becomes a poetic anachronism like horse-drawn. Future Shakespeare could write sonnets about bioluminescent freckles, and children's lullabies might celebrate the glow in the dark patches on their skin rather than counting sheep. The human species that emerges from this long night wouldn't just be biologically distinct, it would perceive reality through entirely new sensory frameworks, making our current experience of darkness as alien to them as cave paintings seem to smartphone users. Evolution under perpetual shadow wouldn't merely change our bodies, it would redefine what it means to be human. Art galleries would become battlegrounds between two warring visions of the future, one faction painting stark, minimalist wastelands under star-speckled black skies, the other obsessively recreating lunar landscapes from memory like medieval monks illuminating lost scriptures. The avant-garde nocturnists might pioneer a radical palette of phosphorescent bio-paints that actually glow in the perpetual darkness, their canvases shifting hues as viewers pass by with retina-adapted eyes. Meanwhile, traditionalists would form underground salons where they teach forbidden techniques for depicting moonlit scenes, passing down the exact ratio of titanium white to ultramarine blue needed to mimic Earth's lost companion in oil. Literature fractures into competing genres overnight. Hard sci-fi authors craft meticulous survival guides for moonless colonies, their pages crammed with schematics for artificial tide machines and axial stabilizers. At the opposite extreme, lunar romanticism emerges as a nostalgic counter-movement, haiku collections where every 17 syllables echo the moon's phases, or epic poems structured in 28 cantos to mirror the vanished lunar cycle. Bestseller lists would feature paradoxical hybrids like "The Moon is a Harsh Mistress Too," Zero, rewriting Heinlein's classic with the tragic twist of its titular character's disappearance. Even children's books transform, with bedtime stories about the old Mother Moon taking on the somber weight of extinction myths. Music faces its own identity crisis. Composers who once relied on the moon's symbolic weight, from Beethoven's Moonlight Sonata to Debussy's Clair de Lune, would hear their works reinterpreted as requiems. Protest songs might adopt tidal metaphors, their lyrics mourning the silenced heartbeat of the sea. The most radical change could come from avant-garde musicians experimenting with zero-G composition, using the Earth's new erratic rotation to create arrhythmic time signatures that physically unsettle listeners. Imagine symphonies where the tempo accelerates unpredictably like a planet spinning out of control, or pop songs whose hooks disintegrate after 6-hour loops to match the shortened days. Film and television undergo visceral transformations. Noir classics like Moonstruck get remade as psychological horror, their moonlit scenes replaced by unnatural LED glow. Blockbuster franchises pivot from superheroes to Tide Warriors, dystopian heroes battling coastal megastorms with jury-rigged gravity tech. The most poignant works might be documentaries splicing archival footage of lunar eclipses with interviews of elderly astronauts, their shaky hands tracing the absent orb against star charts like phantom limb sufferers. Streaming platforms would algorithmically classify content into pre-L and post-L eras, creating generational divides in cultural literacy. Yet from this creative chaos, unexpected beauty emerges. Without the moon's monopoly on nighttime wonder, artists rediscover forgotten celestial muses, the dance of Jupiter's moons, the icy rings of Saturn, the eerie glow of zodiacal light. A new generation of poets substitutes lunar metaphors with inventive alternatives, comparing love to the gravity of absence or solitude to the tide that never comes. The very act of creation becomes an act of defiance against cosmic entropy, each brushstroke and stanza whispering, "We remember what you took from us." This cultural upheaval wouldn't just reflect our loss, it would redefine humanity's relationship with creativity itself, proving that art doesn't merely adapt to catastrophe. It evolves to fill the void. Borders would hemorrhage like unstitched wounds as nations scramble to claim the last pockets of arable land. Regions like Siberia and northern Canada, once frozen wastelands, suddenly become climate ovens primed for wheat and soy, precious real estate as traditional breadbaskets wither under erratic weather. The race to redraw maps would ignite brushfire conflicts, from disputed drone-patrolled farmlands to outright invasions under the pretense of climate refugee resettlement. Picture Russia annexing thawing Alaskan territories for their newfound agricultural potential, or Chinese megacorporations leasing vast Argentine plains as sovereign food colonies. The Geneva Conventions might collapse under new doctrines of soil security, where poisoning an enemy's fields becomes a standard military tactic. Scorched earth policies reinvented for an era of permanent scarcity. Space law would fracture just as violently. The Outer Space Treaty of 1967, which declares celestial bodies as the province of mankind, would be torn apart by corporate lobbyists and desperate governments. Asteroid mining ventures already testing extraction tech on near-Earth objects could find their claims hijacked by superpowers invoking national survival. Imagine SpaceX landing a crew on platinum-rich 16 Psyche, only to face Chinese warships parked in synchronous orbit, citing ancient maritime salvage laws repurposed for space. The moon's absence removes a critical bargaining chip. Its ice deposits could have been shared under international frameworks. Now, with Earth destabilizing, metals and water from asteroids become existential necessities rather than economic opportunities. Legal scholars predict a return to 18th century privateering, where corporate navies escort mining drones while hackers wage silent wars over orbital maneuvering data. The most insidious conflicts might unfold underwater. As fish stocks collapse from tidal disruptions, exclusive economic zones extending 200 nautical miles from coasts become battlegrounds. Nations with robust deep-sea trawling fleets like Japan or Norway could deploy AI scout submarines to vacuum up vanishing schools of tuna, triggering naval skirmishes with starving island nations. The South China Sea disputes would pale next to Arctic feeding grounds becoming militarized free-for-alls, where nuclear-powered fishing factories protected by drone swarms harvest the last krill blooms to process into protein paste. Climate accords wouldn't just be ignored, they'd be weaponized, with embargoes and sanctions leveled against countries refusing to share glacier meltwater or patented drought-resistant seeds. Resource cartels would emerge as the new superpowers, Brazil guarding its Amazonian freshwater reserves like a hydro-powered Fort Knox, Saudi Arabia pivoting from oil to hoarding subsurface aquifers beneath its deserts. Even small nations could wield disproportionate power, Chile's lithium deposits or South Africa's platinum veins becoming more strategically vital than nuclear arsenals. The petrodollar might be replaced by a carbon dollar, backed by verified carbon sequestration capacity, with nations trading emissions rights like medieval indulgences. Meanwhile, billionaires would accelerate their escape plans not to Mars, but to fortified floating cities anchored over underwater mineral vents, their sovereign status enforced by private armies and deep-sea drone fleets. This isn't speculation, we're already seeing early tremors. The US Space Force's creation, debates over lunar mining rights at the UN, and Ethiopia's Grand Renaissance Dam straining relations with downstream Nile nations all hint at the coming wars. Difference is, these skirmishes currently play out in courtrooms and boardrooms. Remove the moon's stabilizing influence, and they escalate to gunboat diplomacy in orbit and tank divisions rolling toward thawing tundra. The ultimate irony, humanity's greatest conflicts have always been over resources, oil, gold, fertile river valleys. Now we face the same primal struggles, but with the stakes magnified by a planet whose rules have fundamentally changed beneath our feet. The battles won't be for dominance, but for the right to survive another decade on a world that's forgotten how to stay balanced. Faced with a moonless sky, scientists and dreamers alike have proposed radical solutions, none more ambitious than building an artificial replacement. The concept sounds ripped from science fiction: massive hollow spheres positioned in orbit, their interiors lined with adjustable gravity generators to mimic tidal effects. One particularly daring design calls for a megastructure composed of billions of interconnected hexagonal panels, each embedded with superconductors to create localized gravitational fields. From a distance, it might even glow like the real thing, lit by internal fusion reactors or sunlight reflecting outer shells, but the engineering hurdles are staggering. Constructing something with even 1% of the moon's mass would require mining entire asteroid belts, and that's before grappling with the energy demands of artificial gravity on a planetary scale. Capturing an asteroid as a makeshift moon presents its own nightmare scenarios. While objects like Ceres or Vesta have sufficient mass, altering their trajectories without fracturing them would require decades of precisely calculated nuclear detonations or ion beam nudges. A single miscalculation could send a dwarf planet careening toward Earth instead of settling into orbit. Even if successfully captured, an asteroid's irregular shape and uneven density would create lopsided tides, potentially triggering tsunamis with each rotation. Some proposals suggest spinning captured asteroids to liquefy their surfaces, allowing centrifugal force to mold them into uniform spheres, a process that would demand more energy than humanity currently produces in a century. The myths surrounding these projects often overlook fundamental physics. No artificial structure could perfectly replicate the moon's unique combination of mass, composition, and orbital resonance with Earth. Tides generated by a hollow sphere would lack the subtle variations caused by the real moon's mascons. dense regions beneath its surface that create localized gravitational anomalies. These imperfections in our natural satellite actually benefit marine life by creating diverse tidal zones. An artificial replacement might produce mathematically perfect tides, but biology thrives on variation, not uniformity. Thermal regulation presents another deal-breaker. The real moon absorbs and radiates heat in a finely tuned balance with Earth's climate systems. A synthetic counterpart made of metals and composites would overheat rapidly under constant sunlight, potentially becoming an orbital microwave emitter unintentionally boiling our atmosphere. Early prototypes using reflective materials inadvertently amplified sunlight into death rays during testing. One accidentally scorched a 5-mile swath of desert before engineers scrambled to adjust the angle. Perhaps the cruelest irony lies in timing. Even if humanity united to construct an artificial moon, the process would take centuries, far too slow to prevent the cascading ecological disasters already set in motion by the original's disappearance. These megaprojects might eventually stabilize Earth for future generations, but only after ours endures the brunt of the catastrophe, the bitter lesson. Some natural systems are too complex to replicate, their value only fully understood in their absence. Our technology can patch holes in reality, but some gaps remain too vast to fill. Underground cities might seem like science fiction, but they could become humanity's last refuge in a world of erratic surface conditions. Picture vast bioreactor-powered caverns stretching beneath mountain ranges, where vertical farms stack dozens of stories high grow crops under artificial sun lamps. Geothermal vents provide heat and energy, while advanced air filtration systems scrub toxins from recycled atmospheres. The technology isn't entirely hypothetical. Norway's Svalbard Global Seed Vault already preserves crop diversity in permafrost, and China's underground nuclear shelters could house millions. Yet the psychological toll of perpetual confinement would be staggering. Studies of Antarctic winter overcruise show increased depression and cognitive decline in isolated environments. Now imagine generations raised without ever feeling sunlight on their skin, their circadian rhythms regulated by dim artificial cycles. Social stratification could emerge between those who control access to surface resources and those condemned to the depths, creating a literal underclass. Genetic engineering offers a more radical solution, rewriting human biology to survive the chaos. Scientists already experiment with CRISPR-modified crops resistant to drought and extreme temperatures. Applying similar techniques to humans might produce variants with thicker subcutaneous fat for insulation, or hemoglobin optimized for low oxygen environments. More extreme proposals include splicing tardigrade DNA, those microscopic water bears that survive vacuum and radiation, into human embryos. The ethical firestorms would be unprecedented. Would governments mandate gene edits as public health measures? Would unmodified, baseline humans become an endangered minority? History suggests such divisions could ignite new forms of discrimination, with climate-adapted elites viewing traditional humans as evolutionary dead ends. Interstellar arcs present the most audacious gamble: self-contained generation ships venturing toward habitable exoplanets. These vessels would need to sustain populations for centuries, with closed-loop ecosystems and strict reproductive controls to prevent overpopulation. The challenges are mind-bending: preventing genetic drift over generations, maintaining social cohesion without cultural stagnation, and engineering propulsion systems capable of surviving millennia in deep space. Breakthroughs in nuclear pulse propulsion or antimatter harvesting could make such journeys feasible within a few centuries, but the risks are existential. A single system's failure could doom entire civilizations floating between stars, their frozen corpses continuing onward as cosmic tombstones. The deeper question isn't technical but philosophical. Does humanity deserve to survive if we fail our first planetary stewardship test? Indigenous cultures maintained balance with nature for millennia. Industrial civilization unraveled it in centuries. Perhaps our resilience lies not in fleeing or forcing adaptation, but in humility. The moon's disappearance would be the ultimate lesson in cosmic impermanence, teaching us that no celestial anchor lasts forever. Survival may depend not on dominating our environment, but finally learning to dance with its chaos, embracing fluidity over control as the fundamental rule of existence. The choices we make in the shadow of this loss would reveal who we truly are, architects of our own salvation or relics clinging to a vanished stability. Across the cosmos, exoplanets drifting without moons tell a cautionary tale, one written in sterile atmospheres and erratic climates. Take Kepler 186f, an Earth-sized world orbiting a red dwarf star. Early excitement about its potential for life dimmed when astronomers realized it likely lacks any substantial lunar companion. Computer models show such moonless planets experience axial tilts that swing wildly over millennia, their poles sometimes flipping to face their sun directly. The result, cataclysmic climate oscillations where liquid water, if it exists at all, shifts between boiling evaporation and global glaciation. Intelligent life would struggle to emerge when stable environments last mere centuries before being erased by the next extreme tilt. The scarcity of large moons in the universe hints at how exceptional Earth's situation truly is. Most rocky planets either never acquire substantial satellites or lose them early in their formation. Mars's pathetic duo of captured asteroids, Phobos and Deimos, exemplify the norm: tiny, unstable companions that offer no tidal influence or rotational stabilization. Even Venus, Earth's twin in size, spins backward with a day longer than its year, its moonless existence likely contributing to its runaway greenhouse effect. Astronomers estimate less than 10% of terrestrial exoplanets boast moons large enough to stabilize their climates. This cosmic lottery means the vast majority of potentially habitable worlds might be rendered uninhabitable by their very solitude. Lunar companionship appears to play a hidden role in fostering technological intelligence. Consider the evolutionary advantages our moon provided, not just stabilizing tides and climate, but serving as an early laboratory for celestial mechanics. Ancient astronomers tracking lunar cycles developed the first calendars. Navigators used its phases to measure time at sea, and its predictable motions helped humanity grasp the clockwork nature of the cosmos. On a moonless world, would intelligent species ever develop astronomy without that glowing classroom in the sky? Might they remain forever bound to their planetary surfaces, lacking the curiosity or navigational tools to explore beyond their atmosphere? The rarest gift our moon offers could be its position as a visible but unreachable challenge. Its stark presence in Earth's sky, showing cratered landscapes and mountain shadows even to the naked eye, taunted humanity for millennia before we finally reached it. That combination, close enough to inspire, far enough to require innovation, may be critical for civilizations to achieve spaceflight. Exoplanets with tiny moons or none at all would lack this perpetual motivator hovering overhead. Their inhabitants might gaze at distant stars but never conceive of crossing the void, trapped by the absence of that first stepping stone into the cosmos. Yet some worlds could defy these odds in unexpected ways. Tidally locked planets permanently facing their stars with one scorching day side and one frozen night side might develop intelligence along their narrow twilight zones. Their civilizations could emerge without ever experiencing true seasons or lunar cycles, developing radically different technologies and philosophies. Perhaps they'd master geothermal energy from constant tectonic stress, or build floating cities in permanent hurricane zones where atmospheric circulation replaces tides. Their version of progress might focus inward rather than upward, tunneling through planetary crusts instead of reaching for the stars. The sobering truth emerges when we study exoplanet surveys. Earth's combination of size, composition, and lunar companionship might be a fluke so rare it borders on miraculous. That glowing orb in our night sky doesn't just light our way, it's the silent architect of everything from our stable climate to our exploratory drive. As we discover more alien worlds, their silent, moonless landscapes serve as mirrors showing what could have been, a universe teeming with life yet barren of thinkers to comprehend it. The difference between a planet that births civilizations and one that merely hosts microbes might come down to a single cataclysmic impact 4 billion years ago when a wandering protoplanet struck Earth just right, spraying debris that coalesced into our unlikely guardian. Without that violent beginning, the night would hold no moon, the tides no rhythm, and humanity, if it existed at all, no stars to reach for. Carl Sagan once called Earth a lonely speck in the cosmic dark, but without the moon, that loneliness would deepen into something far more profound. For all our technological prowess, we'd suddenly find ourselves adrift in the universe, untethered from the celestial companion that witnessed humanity's first steps and guided our earliest dreams. The night sky, stripped of its silver anchor, would become a void reflecting our own insignificance back at us, a cosmic Rorschach test where every star seems to whisper, "You are alone." This existential shift would echo Nietzsche's warning about staring too long into the abyss. The German philosopher believed that confronting a universe without inherent meaning could either destroy us or force us to become the creators of our own purpose. A moonless Earth would test this idea on a planetary scale. Would we double down on mythology, inventing new stories to fill the void? Would science become our secular scripture, its equations replacing lunar deities as objects of reverence? Or would the collective psyche fracture under the weight of cosmic abandonment, triggering waves of nihilism or religious extremism as people scramble to reconcile with a suddenly unbalanced cosmos? History offers glimpses of how civilizations react to celestial disruptions. When Halley's comet blazed across Europe's skies in 1066, it was interpreted as an omen preceding William the Conqueror's invasion of England. The year 1818 became the year without a summer after volcanic ash dimmed the sun, sparking apocalyptic cults while also inspiring Mary Shelley to write Frankenstein during the gloom. These events lasted months. Imagine the cultural shockwaves from a permanent celestial absence. Artists might paint the empty night in increasingly abstract forms, mirroring humanity's disorientation. Musicians could compose works where the silence between notes carries as much weight as the sounds themselves, mirroring the moon's absence. Yet this crisis might also spark unexpected unity. Astronomers have noted how total solar eclipses, brief as they are, often dissolve national boundaries, with strangers hugging in shared awe. The moon's disappearance could trigger a similar phenomenon on a global scale, its loss reminding us that all human conflicts play out on a fragile speck in the void. International rivalries might seem petty when facing axial tilts that could erase entire climates. The same technologies once earmarked for lunar mining could be redirected to stabilize Earth's wobble, turning space agencies into planetary lifeguards. There's a deeper truth hidden in this thought experiment. The moon never truly belonged to us, we belonged to it. Its gravitational embrace cradled the conditions for life to emerge. Its phases gave rhythm to civilizations. Its face inspired myths across continents. To lose it would be like a child realizing their parent was never immortal after all. But this realization carries an inverse revelation. If we can mourn a celestial body, then we're capable of seeing the universe as more than dead matter. Our loneliness would prove we're participants in the cosmic drama, not just spectators. The very act of missing the moon confirms its greatest gift, teaching us that connection transcends gravity, that meaning isn't written in the stars but in our willingness to keep looking up even when the sky goes dark. The most haunting question isn't whether we'd survive physically without the moon, but whether we'd retain our humanity. Would we still recite love poems comparing beloveds to moonlight when generations have never seen it? Would astronomers bother tracking artificial satellites with the same reverence once reserved for eclipses and supermoons? The answer may lie in something as simple as a child's drawing future generations sketching round white circles on black paper, not because they remember, but because some part of us will always reach for the light we've lost. That instinct, more than any technology, would be our species' real triumph over the darkness. Even in the darkest scenarios, human ingenuity flickers like a candle against the void. Take fusion power, long mocked as the energy source that's always 30 years away. Recent breakthroughs suggest we might finally be closing in on this holy grail. A lab in South Korea sustained plasma at 100 million degrees Celsius for 30 seconds, while private ventures like Helion Energy aim to achieve net energy gain by 2028. These aren't just technical milestones, they're potential lifelines. Fusion reactors fueled by seawater-derived deuterium could provide limitless clean energy to power tidal stabilizers or atmospheric scrubbers, buying us time to adapt. The twist: some designs borrow principles from astrophysics, mimicking how stars self-regulate their nuclear fires. It's poetic, using cosmic forces to compensate for a cosmic loss. Then there's terraforming, not just for Mars anymore. With Earth's climate destabilizing, scientists are exploring radical planetary-scale interventions. Imagine fleets of autonomous drones seeding stratospheric aerosols to reflect sunlight, or genetically engineered algae blooms sequestering carbon while producing oxygen. The most daring proposal involves orbital sunshades, vast, adjustable mirrors at Lagrange point 1 that could dial down solar intensity like a thermostat. These aren't fringe ideas. Harvard's Solar Geoengineering Research Program already tests calcium carbonate particles in the upper atmosphere. Critics warn of unintended consequences, but proponents argue we're already conducting an uncontrolled experiment by not acting. The calculus shifts when the alternative is civilization's collapse. History proves our species thrives under pressure. The Inuit didn't just survive Arctic winters, they engineered igloos, tailored parkas, and preserved knowledge through oral traditions. During the Little Ice Age, Dutch farmers invented rotational cropping and windmill-drained polders to feed millions on shrinking arable land. Modern equivalents emerged daily. Bangladeshi architects building floating schools for flood-prone regions, or Israeli scientists drip-irrigating deserts with brackish water. These aren't mere adaptations, they're acts of defiance, proving scarcity breeds innovation as often as conflict. The psychological dimension matters just as much. After the Tohoku earthquake shattered Japan's infrastructure, communities rebuilt around Kizuna, the concept of bonds stronger than adversity. Similarly, moonless nights might inspire new forms of communal resilience. Night markets lit by bioluminescent plants, vertical farms humming beneath artificial suns, even storytelling traditions that recast the void as a canvas for human creativity. These could become the cultural antibodies against despair. Perhaps the ultimate hope lies in our ability to redefine progress. Before the Industrial Revolution, the Maori measured wealth by sustainable harvests, not GDP. Bhutan prioritizes gross national happiness over economic output. A post-lunar world might elevate metrics like stability hours or climate volatility indices, rewarding technologies that harmonize rather than dominate. Fusion reactors could power not just cities but ocean-mixing turbines, while AI optimizes crop rotations in real time as seasons fragment. The goal shifts from restoring what was lost to forging something resilient enough to endure whatever comes next. This isn't blind optimism, it's hard-won pragmatism. Every breakthrough began as someone's impossible dream until physics and persistence converged. The same ingenuity that put footprints on the moon can stabilize a wobbling Earth if we channel it with equal urgency. The darkness ahead is real, but so is the light we carry within. Memories of lunar eclipses, equations predicting tide rhythms, the stubborn refusal to accept oblivion as our fate. However profound our loss, the human mind remains the most adaptable force in the known universe, capable of turning even the night's emptiness into a workshop for miracles. For all its silent presence, the moon shapes our existence in ways we're only beginning to comprehend. Losing it wouldn't just dim our nights, it would unravel the delicate balance that makes Earth livable. Within years, we'd witness coastlines collapsing under stagnant seas, crops failing as seasons spiral into chaos, and entire ecosystems gasping under erratic skies. Centuries later, the deeper scars would emerge, our wobbling planet tilting toward climate extremes, oceans suffocating without tides, and human culture severed from its oldest celestial companion. This isn't just about missing moonlight, it's about losing the gravitational anchor that's cradled life for 4 billion years. Yet this apocalyptic scenario holds an unexpected gift, the chance to redefine our relationship with the cosmos. Right now, private companies eye lunar mining, nations plot territorial claims, and tourists dream of crater selfies. But what if we saw the moon not as a resource to exploit, but as a shared inheritance to protect? The same treaties preserving Antarctica's neutrality could extend to our celestial neighbor, designating it a scientific sanctuary where research trumps profit. Citizen-led initiatives already push for dark sky preserves on Earth. Imagine applying that ethos to ban light pollution on the moon's far side, protecting pristine conditions for astronomy. Supporting lunar conservation starts with simple steps. Backing organizations like the International Moon Base Alliance helps fund sustainable research stations. Pressuring legislators to strengthen the Artemis Accords ensures future lunar activities prioritize preservation. Even stargazing takes on new meaning when you realize those craters hold clues to Earth's past and the keys to our survival. Every photo shared of the moon, every child shown its phases through a telescope, reinforces its value beyond economics or geopolitics. This isn't just about saving the moon, it's about proving humanity can mature beyond short-term thinking. In stabilizing our planet's tilt and tides, the moon taught us that some forces are too precious to replace. Now it's our turn to return the favor, ensuring that when future generations look up, they don't see a warning of what we lost, but proof of what we chose to protect. The next chapter of our cosmic story begins with a single realization: some lifelines aren't ours to cut.